Hello everyone, welcome to the electrical circuit simulation series. In this particular session, we'll study about the application of OPAMP as a difference amplifier. So first of all, let us see the circuit diagram. So we'll be using this particular circuit diagram with OPAMP and two input supplies. Let us see each and every component. So the first component is OPAMP itself, okay? And then we have two inputs. We need two DC power supplies, one at the inverting end, other at the non-inverting end. Then we have resistor R1 of 100 ohms. In this case we are using it for 100 ohms. Then we have the feedback resistor of 100 ohms. We are giving a negative feedback. Then we have other two resistors connected in this particular way to the non-inverting terminal. Both are of 100 ohms. Then we have the ground connection for completing the circuit, and then finally we have the voltmeter. So before starting this simulation, we need to do some settings because we are using this SimulIDE. So in SimulIDE, when we open the settings for the OPAMP and for the supply, in case it's supply, for the supply you will see this would be 5 volt and this would be 0 volt. So we need to set this particular OPAMP for positive voltage as 10 volt and negative V minus as minus 10 volt. Otherwise we won't get any negative reading. So this setting must be done. We will see when we do the simulation. So this setting must be done. So now let us see the calculation part, the output equation for this particular amplifier. Okay, so these are the things, these are the parameters. We have the V1 as the inverting input, V2 as the non-inverting input, and R1 as the input resistor towards the inverting end. Then RF is the feedback resistor, R2 is connected in series here with the power supply, and then R3 from non-inverting to the ground, and this V0 is our output. So these are the parameters we are using, and the values are also specified. Now the gain of the amplifier in this case is RF upon R1. Okay, so this is the gain of the amplifier. Okay, so gain is what? Output upon input. Okay, so if we solve this, we get V2 minus V1 is the total input. Okay, so V2 is the non-inverting end input and V1 is the inverting input. Therefore we are doing V2 minus V1 into RF upon R1. So this output V0 will be of this type. We get, this is the calculation part. Okay, but in our case RF is 100, R1 is also 100, so they will just cancel out. So the total output voltage will be the simple difference between V2 minus V1. So we can control the gain by changing RF and R1. Okay. So in our case both are 100, so the gain is 1. So V0 in this case is V2 minus V1. So let us see if we apply this particular voltage. So the input voltage at the inverting is 2 volt and the input at non-inverting is 5. So if we put the values, okay, we get it as 3 because 5 minus 2 is 3. Okay. Then let us see another example. So in this example we are giving the non-inverting inverting input as 4 volt and keeping the non-inverting as 2 volt almost. This 1.9 is almost 2. So we get in this case as 2 minus 4. Okay, so we get minus 2. So 2 minus 4 is minus. So we will get a negative value because in this case the inverting input is larger than the non-inverting input. So we get a negative value. So this is why it is called as difference amplifier, because the output is the difference of the inputs. Okay. So now let us go for the simulation part. So now we are into the SimulIDE. Let us select the component. So first we select the OPAMP. Take this OPAMP here. Okay, and then flip this OPAMP actually, so that we get the inverting end up, and then do the settings. So we go into the properties, and in the supply we need to make this as 10 volt and this as minus 10 volt. Okay, so this is the settings we have to do. Now next let us select some more the other components. We start with the power supply. Okay, so this voltage source, we need two voltage sources. This is the first, the second one. Then we need resistors. So this is the resistor. I will just connect it here. Then the feedback resistor. Then one more resistor here. Then one more resistor here. We just flip this. then the ground, so we have this ground here, then finally the voltmeter, so this is the voltmeter. Now let us do the connection. The connection is very simple, so we just connect this here, and then connect this to the inverting end, then this power supply, and then this to the non-inverting end. This one we connect it here, and then this to the ground, then this we connect it here, and this is the output. We disconnect this feedback, and then finally the ground. So this is the connection is complete. Okay, now let us turn this on. Okay, this is the thing we have. I just turned it on. Okay, so let us set this inverting voltage as 2 volt. Okay, so it is just 2.0, is almost 2, and now let us set this to 5 volt. Okay, so what we get is 5 minus 2 is 3, so this 2.939 is almost equal to 3, so we get output as the difference. So this is 5, this is 2, 5 minus 2 is 3. Now let us make this as 2, okay, around 2 around, and let us make this as 5. So now your 5 minus 2 is minus 3. Okay, sorry, this is 2 minus 5, so we get minus 3. So 2 is on the positive non-inverting end, and 5 is on the inverting end, so we get 2 minus 5 is minus 3, so minus 2.9 is almost minus 3. So this is how the difference amplifier works. So that's all for this particular session. Thanks for watching.